Introduction. This marks the end of the 7th week of 1 year with calculus. That's about 14.25% of the year and exactly 40% of the event's progress. Congratulations to all those that participated one way or another. We are back again with yet another solution video, and as the pattern goes, the tally of the scores will be at the end of the video. This week we were given 4 derivatives to evaluate. Not just evaluation, but also determine which among the derivatives is different, what makes it different, and determine why that difference occurs. There's a lot to reason about what, how, and why, but all that will be explained in the progression of this video. With no further ado, let's solve. For uniformity's sake, perhaps simplicity, I would like to apply a single u sub for all the derivatives. Let u equal to ax, where a is given as the constant. This implies that du dx is equal to a. That is, if you differentiate both sides, you get du dx is equal to a. For the first part, that is the derivative of sine ax, if we differentiate both sides using chain rule, we will get that the derivative of sine ax is equal to the derivative of sine u with respect to u times du dx, and du dx is equal to a, so we have the derivative of sine ax is equal to the derivative of sine u times a, which is simply just a cos u. Always remember to substitute your value of u. Now this process is the exact same process for the remaining 3. That is the same process I just followed now, is the same that we use for the remaining 3 derivatives. So I'm prepared to use chain rule, which I just did, but in a different style. All that may just differentiate what's inside the function, that is a times x in this case, so I multiply it by the derivative of the function itself. That is, we have the derivative of sine ax, we just do the derivative of sine of ax, which is just a, times the derivative of sine u, which is cos u. So you have a times cos u is a for a sine ax. So you do the same thing for this one. We have the derivative of e to the power of ax. If we derive ax, we get a, and if we derive e to the power of u, we get e to the power of u. So the derivative of e to the power of ax is same as a times e to the power of u, and e to the power of u is same as e to the power of ax. So the derivative of e to the power of ax is equal to a times e to the power of ax. Let's go to the third one now. We have the derivative of the natural log of ax. I will let you guys solve this one or just look at the solution. Now also go back. I explained everything using text. I'm just using my voice so that it will not sound like it is AI generated. That's why I'm using my own voice to speak. But you can go through the working. The working is very much explained in text. If you still understand, you can also go to the comments and I will explain more in the comment section. For the third one, the derivative of natural log of ax is equal to 1 over x. And for the fourth one, the derivative of square root of ax, if we let theta of x equal to square root of ax, then the derivative of theta of x is equal to the derivative of theta of x divided by dx times du du. Since the u over du is just 1, you can just multiply it. You can multiply it because m1 is a multiplicative identity. So if we change the numerators, we have the derivative of ex with respect to u is equal to times du dx equal to the derivative of theta of x, and that is simply just half of the square root of a divided by x. So the derivative of square root of ax is equal to half of square root of a over x. And I said my voice may not be perfect because I am not explaining the video. I'm just making not sound like it's AI that video. That's why I'm using my voice to explain. But I make sure I explain everything in that text very well. Okay, we have below are the derivatives. That is, we have to determine which of them seems odd, what makes it odd, and why. The first derivative, that is the derivative of sine ax, is equal to a times cos ax. The second one, the derivative of the derivative of e to the power of x is equal to a times e to the power of ax. And the third one, the derivative of natural log of ax is equal to 1 over x. The fourth one, the derivative of square root of ax is equal to half square root of a divided by x. You should look at the four of them and determine which of them is odd among all of them, among the four. Okay, these are the solutions. For the first part, which of them is different? Without much thinking, the derivative of natural log of ax is equal to 1 over x, and that is the odd one. The second question is, what makes it different? What makes it different is the fact that a is not present in that derivative. In the remaining ones, a was present, that is a the constant, was present in all the derivatives, but in this one, a is not present. The third question, which is the most important question, is why is that difference not changing the fact that that is the actual answer? Now, if you separate the ax into two parts, you have natural log of a plus natural log of x, so that is logarithm identity. And if you differentiate a constant, that is a, it cancels out. So just like differentiating x, and that is just 1 over x. So no matter what the value of a is, that solution will be 1 over x and not anything to do with constant. Now these are the picture solution. The picture solution is really helpful. That is, sometimes I use different methods in the picture solution than the method I used in the video solution, because maybe I wanted to explain more in the video solution or one thing or another. With picture solution, I wanted it easier. But this is the picture solution. You should check it out. And okay, that has already moved on. Okay, this is the closing remark now. This is the end of this video or the video. I hope these solutions put forth was understandable. I try my best to give out the most understandable solution as possible. A big thank you to Professor Mullen for this question. If you would like to send any probable questions to or the one you will calculus, you can send it to my email abdullah@gmail.com. Okay, this is my face and this is the weekly report. There are no participants. There was nobody participating, but I'm still going to continue. Okay, so thanks for watching at IgweMatics, then animation. This is one year of calculus week 8 for next week. The question will show after this animation. If you would like to check out the video, when the video is uploaded, the video will show in this particular place. But for now, the video will not show because I've not made it yet. But by the end of next week, you will see the video showing this part. Yeah. Like, share, and subscribe. Stay excited.